In Lesson 2 of Section 3, we are going to carry out a couple of experiments. Not science experiments, but probability experiments. In doing so, we will generate a discussion on theoretical probability and experimental probability. Consider tossing a coin, a fair coin, 20 times. It could be a nickel, a dime, a loonie, a toonie, a quarter. It does not matter, as long as you have a fair coin, which means it has an equal chance of turning up heads or tails. If you toss this coin 20 times, how many heads would you expect to get? How many tails would you expect to get? And why? If you have thought about these questions as they have been posed here, I'm thinking you came up with an expectation of getting 10 heads. You would expect to get 10 tails in 20 tosses. Why? We have learned that the probability of tossing a heads or a tails is 1/2. One favorable outcome, whether that be heads or tails, compared to two possible outcomes, those being your heads and tails. If we toss the coin 20 times, we can write an equivalent fraction to determine how many heads or tails we would expect to get. The equivalent fraction, if I multiply numerator and denominator by 10, is 10 out of 20. Hence, 10 heads or 10 tails. These expected probabilities are the theoretical probabilities of the events occurring. It is based on analyzing the possible outcomes in a logical way, as we just did. What if we conduct the experiment? What if we actually toss the coin 20 times? Will our results be the same as what we expect? Will we actually get 10 heads and 10 tails? The results of an experiment will give the experimental probabilities of the events occurring. Let's do this. In our experiment, we will use whatever face, heads or tails, we can see on the screen when we toss the coin. If we are unable to see a face, we will conduct that particular trial again. You, by the way, are certainly more than welcome to conduct your own probability experiment by tossing a coin 20 times. Let's try it. I have my quarter in the bottom portion of your screen, and this has been set up to toss randomly. We will tally our results in the table. Here we go. Tails. And each time I will reset my coin. Tails. Heads. 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 Tails. 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 5 for tails so far, 3 for heads. Tails. Tails. Heads. Tails. Barely see the tails on that one, but it is visible. Heads. 13 trials done. Tails. Heads. Tails. heads, heads, tails. One more. Heads. 20 trials completed. We note that we obtained 9 heads and 11 tails. Our experimental probability then for heads would be 9 out of 20, and our experimental probability for tails, 11 out of 20. We will only express these probabilities as fractions for now, though we could write them as ratios, percents, and so on. And if we compare these probabilities to the theoretical probability, which was 10 out of 20, or a half, we do note that our experimental results were pretty close to the theoretical, but they are not the same. Is it possible that they could both be equal? Sure. We could toss and get 10 and 10. It's possible we could toss all heads. It's possible we could toss 20 tails. That would be unlikely, but possible. We could easily try this experiment 10 different times and get 10 different results. And it is certainly not unusual for the experimental and theoretical probabilities to differ. If at this point you would like to pause and try your own experiment with the coin, go right ahead. See if your results are the same or different than the ones we obtained in this video. When you are ready, proceed to the next video in this lesson, where we will conduct another probability experiment.